It powers our phones, it lights up our homes. I mean, it runs our entire modern world. I'm talking, of course, about electricity. But have you ever really stopped to think about the basic science of it? Like, why can some materials carry all that power while other materials just stop it cold? Well, let's dive in. Okay, take a look at this. An ordinary electrical plug. You've probably used one of these today already, right? We just don't give them a second thought. But these little things are the gateways for all the power that juices up our devices. And they're holding a really fascinating secret in plain sight.
So here's the big question. Why are they designed like this? I mean, why use two totally different materials? You've got these shiny metal pins on one end and this tough plastic body that you hold. Believe it or not, the answer reveals one of the most fundamental rules of how electricity actually works.
All right, to solve this puzzle, let's break it down. We're going to start with the metal pins. This is our introduction to a whole category of materials called electrical conductors.
So what in the world is a conductor? It's simple, really. A conductor is just any material that lets an electrical current flow through it super easily. Think of it like a freshly paved, wide-open highway for electricity.
And the thing is, conductors are everywhere. Stuff like steel, aluminum, copper, these are all fantastic conductors. And here's a fun fact for you. Silver is actually an even better conductor than copper. It's just way more expensive, which, is probably why the wiring in your house isn't made of solid silver.
And just like that, we've solved the first half of our puzzle. The pins on a plug are made of metal because metal is a great conductor. Its whole job is to make a nice, clear path for the electricity to flow from the wall, through the cord, and right into your laptop or your phone.
Okay, that makes sense. But what about the other part of the plug? The plastic part that we actually hold on to? Well, to understand that, we need to talk about the total opposite of conductors, electrical insulators.
An insulator is exactly what it sounds like. It's a material that does the opposite. It blocks the flow of electricity. If a conductor is a superhighway, an insulator is a massive concrete roadblock. Dead end.
And just like conductors, these insulators are all around us too. You see them all the time. Plastic, wood, rubber, even things like glass and ceramic. These guys are basically the bouncers of the electrical world.
And there you have it, the final piece of our puzzle. The body of the plug is plastic for one very important reason. Plastic is an excellent insulator. Its entire job is to keep all that powerful electricity safely inside, which protects you from getting a nasty and dangerous shock. So we've figured out that metals conduct and plastics insulate. But the really big question is, why? I mean, what's actually happening on a microscopic level that makes them behave in completely opposite ways? Now we get to the really cool science part.
The key to this whole thing is a super tiny particle you've probably heard of called the electron. Everything comes down to how these little guys behave. So what is the real fundamental difference that makes one material a conductor and another an insulator?
And here it is. It really is all about the electrons. In a conductor, the electrons are kind of loose. They're free to jump from atom to atom, and that movement, that flow, is what we call electricity. But in an insulator, the electrons are held on super tight to their atoms. They can't go anywhere. So free electrons mean go, and lockdown electrons mean stop. It's honestly as simple as that. Now this idea isn't just for electrical plugs. This fundamental principle, this dance between conductors and insulators, is the foundation for pretty much every electrical thing you use. Let's look at a couple more examples.
So picture an electrician working on some wiring. You almost always see them wearing those thick, heavy-duty rubber gloves, right? Now that you know about insulators, I bet you can guess why.
You got it. Rubber is an amazing insulator. Those gloves create a protective barrier, stopping electricity from flowing through the electrician's body if they happen to touch a live wire. It's a life-saving application of the super simple principle. Okay, now let's go from something you wear on your hands to something absolutely massive. Look up at a big power line tower. You'll notice the high-voltage wires aren't just tied directly to the metal frame. Nope, they're held in place by these strings of glass or ceramic discs. So what are those things doing?
Right again, those discs are insulators, and they are crucial. Without them, all that high-voltage electricity would just zip right down the metal tower and into the ground, which would be a huge waste of power and incredibly dangerous. So the insulators hold the wire safely, blocking the electricity from going anywhere it's not supposed to.
All right, we've covered a lot of ground, from the simple plug in your kitchen to massive power lines. You totally get the core idea now. So, to wrap things up, I've got one final challenge for you. just to put your new knowledge to the test.
So here are two facts. Gold is one of the best electrical conductors on the planet, and glass is one of the best electrical insulators. So here's the final question for you. Based on everything we've just learned, can you explain why? I'll give you a hint. The answer has everything to do with those tiny, powerful particles, the electrons. Something to think about the next time you plug something in.